Welcome back, grade 12s. We're in exercise 7, question 3. And then you just get excited because it's not just question 3. It's question 3A, 3B, and 3C. 3 questions in one. But for all the jokes aside, one nice thing about having a multi-part question is that we can really invest our time into the diagram and not have to relook at a new diagram. But it also meant that I spoke for a long time. Well, aren't we all lucky? So, okay, let's have a look here. In the diagram, everything that's written up here is in the diagram. I've looked at it. I know that there's beta and alpha and everything else. And just note that alpha was, or is, this whole angle here at n. It's KNM. And beta is just this little angle here, KNL. So maybe we just want to fill in some other bits in the diagram because there's so much that we're going to do, and there's an alpha minus beta and all sorts going on here. So if this whole angle here is alpha and this little part is beta, then this little part here is the big angle minus the small angle. Okay, so it may or may not be useful, but I'm kind of preempting that there's an alpha minus beta there. So hey, this means we could work in this little triangle NLM. There are 3 triangles of the diagram. We want to be able to move seamlessly between them. Okay, other things we might need. Well, in the big triangle, NMK, there's another angle, this angle here at the top. Well, this is 90 on the bottom right here by M. N, the whole of N that is alpha. So therefore, this top angle here is just 90 minus alpha. Okay, therefore, we could work out a few other things. I don't know which ones we're going to need here, but probably worthwhile spending the time finding them, particularly in an exercise. We're not in a test situation where now we're trying to do, but maybe in a test this is a good idea too. Just going, what can we find fairly quickly without too much effort? Well, if that's 90 minus alpha and that's beta, we could also find what this is, and we could also find what this is over here. I'm going to start with the bottom right here. This is 90. This is alpha minus beta. So we're going to need another alpha, and we're going to need to subtract alpha minus beta. Alpha minus beta to find that angle. I'm leaving it in that form because if at some stage, say, we're taking the sine of that angle, alpha minus beta, then we'll go, oh wait, that's just a co-ratio. That's the same as cos of alpha minus beta. Okay, so that's why I'm leaving it as 90 minus and not distributing the minus in, because we can make these manipulations later. Okay, then what we can also do over here is find out this last angle. As I said, I don't know which ones we're going to need, and I genuinely don't, because sometimes you do these in slightly different ways each time. But this whole one needs to add up to 180. So this is 90 plus alpha minus beta, using angles on straight line, or perhaps using the top triangle here. 90 plus 90 is 180. We've got a minus alpha and a plus beta and a minus beta. Okay, may not have been worthwhile to find all of those, to find these questions, but as I said, we're kind of getting into these, so maybe that is 3.5 minutes very well spent. Okay, show that NL equals x cos alpha over sine beta. So I guess we just need to keep thinking to ourselves which triangle we're going to work in. So if we looked at triangle KLN, it's got NL, let's just see the one that I'm talking about. If we in this triangle up here, let's see if that's going to give us the information we need. It's definitely got an X, which we need. There's an X, and it's the only bit that has an X, so that's why I've gone for that triangle. And then it's got an alpha and it's got a beta. So things are looking up. It's not a right angle triangle, so we're going to have to use sine or cos rules, not just sine, cos, tan type idea. Okay, well, NL is what we're trying to find. So I always think, sure, I always hope that we can get the sine rule. It always feels like the easier one. So NL, well, we've got that side, and we've got the angle opposite it. It's 90 minus alpha. So NL over sine 90 minus alpha equals, let's pick another side. Well, we've got to choose x, right? That's one of the variables that we're trying to get to. So x over sine beta. Okay, things are looking like we're almost there. We want NL to be the subject of the formula. So we've got x over sine beta times sine 90 minus alpha. But wait, that's just a co-ratio, because we're trying to turn that into cos alpha. It's pretty much given us what we need to do. NL equals x sine 90 minus is the same as cos, and on the denominator we've got sine beta. Okay, so there we are. That's part A done, and perhaps we'll use this in the next one. Oh, we definitely will use it in the next one because it says hence. So hence shows something. So now we've got what this side is as well, NL. I'm not going to write this mess in the diagram. I feel like the diagram is going to get too messy. So I'm just going to leave that and go put a little dot there. It's my own indication that I know what NL is, so we can sub it in next. Okay, so for the next one, we're trying to figure out which triangle can we work on that we can find LM. Well, LM is only in one of those triangles, so maybe you can see it while I find the right pen here. Come on. We've got LM as that part there. So almost feels like we would definitely work in this triangle at the bottom here. Now it's a right angle triangle, so we may well just use, sine, cos, tan straight up. And we're trying to find LM. So, boop, boop, boop. Okay, so we're trying to find LM. We could either use the sine rule or just use, say, sine directly or cos directly. So we're trying to work with an alpha minus beta, sine alpha minus beta. So perhaps let's look what sine alpha minus beta is. It wasn't in our formula before, so that might be what we need. Well, that's opposite over hypotenuse. Well, the hypotenuse is what we just found. Well, that's rather convenient. LM's the subject of the formula. So what you noticed I did before was I've always manipulated this equation while it's quite simple. So there we go. LM's now the subject of the formula. And now we can just substitute LN or NL, that's the same thing, and go, well, LM equals LN or NL, which is x cos alpha. I'm just copying the one from the left there, sine beta, and we're multiplying that by sine alpha minus beta. Okay, well, that's quite useful. So I'm going to rub this out. That's what we need to find. There's another hence on its way, so we're going to have to keep going. So we've got LN. We've just worked out what LM is as well. So I'm putting a little dot there so that I know that I've got that line segment. Hence, show that LM equals that whole mess there. Okay, well, there's going to be a bit of work to do here, but we can probably do it directly from here. We've got what LM is, x cos alpha sine alpha minus beta over sine beta. So let me just put that over here. LM equals, this is part C now. We've got x cos alpha sine beta. Now it's almost looking similar to where we're trying to go to, but there isn't an alpha minus beta. There's sine 2 alpha, there's cos beta. So let's use our compound angle formulae and go, well, just reach for it. You've got your formula sheet there, and say we can change sine alpha minus beta to, what was it? It was the sine cos minus cos sine. Is that one? I always have to recheck the formula, I'll be honest. So I've got my formula sheet down here, looking at it, sine alpha cos beta. Maybe you use them enough that you go, yes, I remembered. I don't need to search for the formula sheet. You need to know them well enough to recognize them, but I always just double check myself. Okay, so there we go. We're getting somewhere, and we're going to play a whole lot of algebra now, and hopefully it will turn into what it's meant to turn in. I say hopefully, I genuinely feel like that, and I think, yeah, I back myself that it should get there, but I don't know. Let's multiply this and then see where we get. So we've got x cos alpha sine alpha cos beta minus x cos squared alpha. Okay, well, that's looking good. That's hopeful. Times, I'm just written beta. I meant to write sine beta. Times sine beta. Okay, well, there's a sine beta in the second term of the numerator. So if we took it out separately, then we could split this fraction up and have the first part, x cos alpha sine alpha, it's quite a lot to write, over sine beta minus this second part divided by sine beta. I'm going to show it just to make sure that we've got it clear here. But you can always see that you're going to cancel those sine betas over there. Dunk, dunk. So at least you've got minus x cos squared alpha. Now, if you look back to where we're trying to get to, the second part is already done. So we can feel proud of ourselves because the second part, there's nothing left to do. This is x cos squared alpha. So we just need to manipulate the first part. So we need to change that, hopefully, to this thing here. Well, let's see. There's almost like a little trick here. We've got cos alpha sine alpha. And we're trying to turn this into sine 2 alpha. So just a little bit of working space here. I want to, maybe you can see it already and you're like, okay, I can see this through. Great stuff. Exit the video. But maybe not. And you think, wait a second, I know that sine of 2 alpha is 2 sine alpha cos alpha. But here we've only got cos alpha sine alpha. So it'd be nice if this was 2 sine alpha cos alpha, because then we could change that into sine 2 alpha. Well, I'm just going to cheat and make it that. But wait a second. What you do to the top, you do to the bottom, and the fraction's the same, right? We've just multiplied by 1. Well, there we go. That's easy enough, because now our first term, Lm, equals x 2 cos alpha sine alpha. Well, that's just sine 2 alpha. We still need to multiply this by cos beta. The denominator is 2 sine beta. And with a bit of luck, that's looking close to what it's meant to. Oh, it's all the way up here. X sine 2 alpha cos beta 2 sine. I think that looks the same, right? There's so much stuff going on here. I'm going to screenshot that and just go, let's check. Are those two the same? Yes, they are. Excellent stuff. Cool. Well, since those are the same, we're done. Put the obligatory smiley face at the end. I'll see you in the next one.